Hi class, welcome to the workshop on modeling Facebook. We're going to use this workshop to introduce the basic concepts of databases and then allow you to apply those database concepts to figuring out what's going on behind the scenes in Facebook. I think this is a wonderful way for you to tear back the covers on any application that you use to try and figure out how do they do what they do. Almost everyone puts their information in a database, so trying to figure out what the database looks like behind any application that you use is always a good thing to do. So I know you've gotten an introduction to database concepts elsewhere in this course, but we'll go through it one more time just to make sure. Okay, so TAs, I'd like you to pause the video here and ask the class, what's a database? Get some ideas back about what a database is and what the students think about it. Here's my answer to what a database is. A database is simply a spreadsheet with one added part. A spreadsheet, as you know, is a place where you can make tables. Each row in the table is one item of information, and each column in the table is one attribute about one row in the about one item of information. For example, if there's a person in each row and it has a name, address, and phone number, then each row represents a person and each column represents some attribute or some quality of that person. We all know that. You've all used spreadsheets before for one thing or another, but now think about it as a table that is about something. In this case, it's about a person, and it has three qualities. Each person has three qualities: a name, address, and a phone number. As long as they're in this table, there'll be a person, and each person has those three attributes. That's a really important thing, and it allows you to keep your information very well organized. So in Facebook or any other application, they are very well organized, and all the information that they collect has a tidy place to go somewhere in someone's row and column. So what's a database? A database is exactly like a spreadsheet, only in a database there's lots of tables, and all those tables are connected. So this diagram means nothing more than to show you that in even a very small database, there may be lots of different tables, and all those tables are connected together. Each table holds its own kind of information, and the tables are connected so that you can build up sophisticated aggregations of information. We'll talk more about that in a moment. Okay, pause the video here again, and class, name a site, some site that you go to, Tinder or Twitter or anything else that starts with a T. Find some site that you go to and think about what they might put in their database. What kind of data is in the database of this system? Okay, let's start on the first major concept of databases. Databases have tables. As I told you, a table is just like a table in a spreadsheet, even if it's in a database, and it holds information about one type of information. What you see here is the task table. This is actually the task table from the G-class system. And each row is a task. You can see the tasks: fill-ins, vocabulary quiz, face-offs, etc. Those are tasks that hopefully by now you're pretty familiar with. And there's other information associated with a task. For example, tasks have a certain amount of points possible, and they have a number of points expected. So each row is a task, and on each row is information about that task. For example, its title, its points possible, and its points expected. So that's the basic idea. We take all the information about tasks, put it in this one convenient table to keep them organized. That's what tables do for us in databases. Okay, now let's get started on Facebook. Bring up Facebook, and class, tell us what some of the tables in the Facebook system might be. What kind of tables do you think Facebook has in order to capture all the data that they present to you on the Facebook screen? Okay, point 2. We know about tables. Tables have rows and columns. As I've said, each row represents one entity, one item in the table, and each column represents some extra piece of information about that. So each row in this table, this is the task table, is one task in G-class, and each column has one particular piece of information about that task. The title column has the title of the task. The points possible column has how many points are possible in that task. The points expected column has how many points are expected for the course in that task. Okay, so that's a table. Tables have rows. The rows are items in the table. They're one individual thing, like in this case, one task. And the columns have attributes. Notice that some of these columns are numbers and some of them are text. Columns also have constraints or data types. We'll talk about that at a different time. Okay, going back to Facebook. Suppose there's a person table in Facebook. Go and figure out what some of the columns might be. Look on the Facebook page for people and decide what some of the names of some of the columns might be on the in the Facebook system for the person table. Now, granted, there really probably isn't a quote-unquote person table in Facebook, and in fact the way that they use databases, as we've talked about at other parts of the courses, is really special because there's such a huge database. But let's just simplify things and imagine inside Facebook there's a person table. Inside that person table, what might the columns be? Okay, next thing. Tables have IDs. In fact, each row of each table has an ID. Each row, like each task, is an entity. It's a thing. And to identify entities in this world, we use IDs. So each row in a database has an ID. And you'll see that in every one of the examples that I've given you so far and the examples going forward, that the table pretty much starts with an ID. What's the number that identifies this item uniquely in that table? So that's a key concept, and we'll be using that in just a moment. But before we do, TA will give a bump for the person who can produce from their pocket the most unique IDs. So an ID, for example, is your driver's license number. That's a unique ID. Or your passport number, or your social security number. Who in the class can find on themselves right now the most different IDs that all describe them? So look around in your pockets, find as many as you can find, and we'll give a prize for the one who has the most. Okay, we know that tables are the place where the information is stored in a database. Tables have rows. Each of those rows is one item. Each of the columns is one attribute of those items. The final thing, and probably the most important, well, probably the most complicated thing anyway about tables, is that tables have relationships. You know in the G-class system that each of those tasks is part of some different accomplishment. You know that the accomplishments are learner, speaker, thinker, writer, and builder. Each of those tasks falls under one accomplishment. So we create one table for tasks, we create another table for accomplishments that has all the information about the accomplishment, and then we link the two together. The accomplishment table is linked or related to the task table in order to say which accomplishment each task is part of. So notice column 1 here has the ID. That is the ID of the task. Each task has a unique ID. Look in the accomplishment table. Column 1 of the accomplishment table also has an ID. Each accomplishment has a unique ID. Now don't worry that some of those numbers are the same for task IDs and accomplishment IDs. It really only matters that the number is unique inside the table. So there's only one ID of 1 inside the, there's only one ID of 3, let's say, inside the task table, but notice there's also an item with the ID of 3 inside the accomplishment table. Don't let that confuse you. The IDs can be the same in each of the tables, but they have to be unique within the table. Okay, so back to the point of this slide. Each task has an accomplishment. So notice there are 3 tasks that have in column 2 a comp ID, which stands for accomplishment ID. There are 3 tasks that have a 3. That 3 is exactly the same 3 that's in the accomplishment table. That's what links the task table to the accomplishment table. The task table has an accomplishment ID in it so that you can say that each task is part of one accomplishment. 3 tasks have the accomplishment ID of 3. That means that 3 tasks are part of accomplishment number 3, which happens to be the speaker accomplishment. So this is a kind of a complicated concept, and it might take a while for it to settle in, but think of it this way. Each table uniquely describes some kind of thing. One table uniquely describes a task, the other table uniquely describes an accomplishment. How do you connect tasks and accomplishments? You have to somehow span across those 2 tables that have different information in them. By sharing IDs, by putting the accomplishment ID in the task table in this case, we can link together the accomplishment table and the task table to say which accomplishment each task is part of. Okay, now have a look at your Facebook tables, all the tables that you brainstorm that might be in Facebook, and try to figure out what some of the relationships might be. What tables have to go together? So I'll give you an example. Suppose you said there was an event table in Facebook, and you said there were people table. Well, there was a people table and an events table. Well, when a person gets invited to an event, that means there must be some connection between the people table and the event table. Don't worry right now about the details, just get the concept that if there's events in one table and people in another table and people are invited to events, there must be some sort of relationship between the people table and the event table. Otherwise, we wouldn't be able to forge that idea that people are attending events. Okay, let's move on. Let's model Facebook posts. And I apologize for the typo here. Let's model Facebook posts. To do this, I'll use a spreadsheet. If you want, you can use what's called an entity relationship diagramming tool, like the one found at lucidchart.com. But don't feel like you have to do it. It's a little bit easier to do it in spreadsheets, and that's what I'll use as well. Okay, here's a post. This is a typical post from Facebook. You see the little box drawn around it. It has the picture of the guy who made the post, the guy's name, the text of the post, and then it falls somewhere along a timeline depending on when Doel posted this post. So in a single table, we can get all the information that we need. So bring out a spreadsheet and try to figure out which spreadsheet table and what all the columns would be called that would allow you to get this information on the screen, that would allow you to keep track of all the posts. So one single easy to understand table that captures all the information that you see on the screen. We'll stop the video here, and then when you've had a chance to do it, we'll go on and show you what one possible answer is. Okay, here's a possible answer. We have a person table, and the person has a name. There's his name, Doel Eugenio. That's, by the way, the admissions advisor for the iSchool. If you're interested in iSchools, that's the guy to talk to. Each person has a picture. There's Doel's picture. Each person has a post. There's the post. The technology field needs more than 20%, blah, blah, blah. There it is in column C, the post. And the date time is March 12th, and that puts it somewhere on the timeline. See how simple that is? I just took all the little bits of information that I saw on the screen, and I put them somewhere in a table to keep track of them. Now I have a nice, clean place where I can keep all of my information about people along with their posts. But I hope you're seeing that this is a really limited approach, because what if Doel makes a second post, which he eventually will? What do? Put in a post 1 and a post 2 column? No, we're going to go with a different approach that's going to give us a lot more flexibility, and I'll be with that one in just a moment. So, take this. Here's the same post, and now we want to account for the possibility that Doel might have multiple posts. So create two tables, a person table and a post table. All of Doel's posts go in the post table, but all the information about Doel himself goes in the person table. So while you're making a person table, be sure to break Doel's name into 2 or more columns, because his name has 2 or more parts. So create a person table, put all the information about Doel in that person table, create a post table, put all the information about his posts in the post table, and then give each person and post an ID so that we can connect the person and their post. All right, give that a try, and in a few minutes we'll come back and give you a possible answer to this exercise. Okay, here's my possible answer. I have a person table and a post table. Notice I've added an ID to each of those tables. To keep things straight, I've put the IDs as 100 and 200 in the post table, but 1 and 2 in the person table. So now I have Doel, and I put somebody else in there just to show you a couple of rows. The first name still points to Doel's first name, the last name still points to his last name, the picture still points to his picture, but now the post text is in the post table. This just happens to be one of Doel's posts. He made another post 1 minute earlier, and that's, oh sorry, someone else made another post 1 minute earlier, and their post is in the post table as well. But Doel made a post. It has an ID of 100. It has the person ID of 1, which points back to Doel, thus linking the post to the person. Notice person ID 1, the ID of Doel is 1, so therefore that's his post. At 3 p.m. on March 3rd, 2015, that is what positions it in the timeline. And the post text is what you see on the screen. So we had a simple approach where there's just one table, and we have a more useful approach where there's a person table and a post table, and now I can link all of Doel's posts to his personal record. Okay, we're going to do one more example. Model this. So start from our same 2 tables, and if you don't have the tables that I had, you might want to start from those 2 tables from the last approach so that you have everything accounted for. Add only one new table, in order to make this screen happen. Notice, and also not only add one new table, but also enhance the tables that you have if necessary in order to make this new screen. So let me point to some of the things that are different. We still have a picture up there. It's a different person now, Anna Mars, but we still have the picture and the name, and we still have a post, right? Just like before. But now there's a few more things in there. We have where the post was made. See translation, don't worry about that for this exercise. Where the post was made, CBS library, and the post itself also has an image. So that's thing one. Posts are now more robust. They're more rich than the posts were before when they just had a picture of a person, a name, and a text string. In addition, and this is the harder part, the posts now have comments. How does a comment get put on a post? One more table ought to do it, to link comments to posts and comments to the people who made the comments. So it's a little bit hard. So we'll give you some chance to play around with it, and then we'll come back and give you the solution, or a solution. There's never the definitive solution to database issues. It's just a solution that you believe will work in this case. Okay, I would like you to add the one more table and call it comment, and then we'll come to the answer in just a moment. Okay, here's a possible answer. Notice we still have the person and the post, and the only thing I did to the post was I created a couple of new columns there, the location and the picture, because posts now we know can have locations and pictures. This last one, post ID 300, took place in the CBS library, and we're going to call that picture Gandalf.jpg. So notice the person table and the post table are linked the way they were before, and the post table has been enhanced. It's been augmented to take into account two new pieces of information, location and picture. Now let's look at the comment table. Notice that a person makes a comment on a post. So some person made some comment on a post, and this first comment is from Nora Maria Matti, and so Nora Maria Matti, or Marie Matti, is a person in our person table. She's person number 4. Anna Mars, who made the original post, is person number 3. The post is attributed to Anna, as it shows under post 300, a person ID of 3. That links the post and the person table together. But how about the comment? First of all, the comment was made by a person, and in this case it's Nora and Anna, so the people who are making the posts are person 4 and person 3. So there's a link between the comment table and the people table because every comment is made by a person. There's also a link between the comment table and the post table because every comment is a comment on a post. So look at that first line there, it's commenting on post 300. Second line, commenting on post 300. Third line, commenting on post 300. So now we have 3 tables all interrelated. A person makes a post, a person comments on a post. So the comment table has to reference, it has to point to the person table because there's a person making the post, and the post table because the person is making a comment on the post. Okay, in addition to the person and the post, there's a comment, a date and a time, and whether or not they liked it. The like is behind that little like button, so when you like it, there's the like button. When you push the like button, it registers that there. The comments were made at a certain date and time, and the comments have certain content. They have text to them. And you'll notice that all the content here is in Danish, but it really doesn't matter. It could be in Chinese, and we'd still be able to see what's happening because we're looking at it from a data approach. Okay, a lot of information there, and I'll let your TA introduce you to the original work for this workshop. But I want to let you know that the same information that I presented here is also in G-Class, and so you can find the content in G-Class on databases if this is unclear to you, and go over it again. For the original work, you'll be doing just like you're doing here, putting together different tables and saying how they're all connected in order to make a particular piece of user interface happen.